Hello, my name is David Murray, Product Manager here at Lumension. The purpose of this video is to introduce and demonstrate the Lumension Application Control module, part of the Lumension Endpoint Management and Security Suite, and a core component of the intelligent whitelisting solution. I'm going to demonstrate the Lumension Application Control module, but first, I'd like to frame the discussion a bit. Today, businesses face mounting IT security challenges in a variety of areas. Increasing threats from exponential malware growth and much more sophisticated malware. Visibility and control issues, such as end users with local admin privileges and Web 2.0 delivery mechanisms. And advanced persistent threats, or APTs, which use a wide variety of techniques to gain illicit access to valuable organizational data. All of these lead to more point products being used to deliver the necessary protection, which results in greater complexity and means higher IT burden and costs. Let's look a little more closely at the threats which organizations face today. The first computer virus, which was called Creeper, appeared way back in 1971. And since then, malware has gone from proof of concept to teenage hijinks to a serious business run by crime syndicates. This has resulted in increasing volume, a compound annual growth rate of about 55% over the last several years. In 2012, we saw an average of 2.75 million new pieces of malware per month, according to AV-Test, or about one a second. We've also seen increasing sophistication. You can now buy malware kits for about $1,500 per year, with full online and telephone support, performance guarantees, checkbox vulnerability selection malware delivery. And malware is increasingly targeted. These kits also include a host of malware evasion techniques like obfuscation, bit switching, and so forth. The Application Control module delivers a solution to these challenges. It provides better security, more effective and proactive protection against today's targeted and sophisticated malware threats. It provides improved visibility and control by identifying and controlling what applications and executables are allowed to run in your environment. And it provides a simplified deployment and automation method, with a wizard-based policy creation, automated whitelist maintenance, and powerful event auditing. All of this leads to a lower total cost of ownership, with greatly reduced operational costs due to reduced malware infections, fewer help desk calls, reduced number of remediations required, and delivers increased user and IT uptime and productivity. Now I'm going to go ahead and show you how the Lumension Application Control module works. Rolling out application control in an organization is a four-step process. There's Discover to gain some visibility into the applications in your organization. There's Define to set up your policies, and then Enforce to move into actual enforcement mode, and then finally Manage, the ongoing management. Let me show you how that is accomplished. This is the Endpoint Management and Security Suite console, through which the Application Control module is delivered. Rolling out application control in an organization where you've got non-standard images and your end users have had local admin rights for some time can be challenging because it's difficult to identify all of the executables within your environment. So when you're trying to build and deploy a whitelist and enforce by that whitelist, you have to be very careful that you have identified all of the executables within your environment. However, in a dirty environment, that's a bit difficult to do. So with our Application Control module, we've introduced the concept of Easy Auditor and Easy Lockdown to help ease that deployment, the initial deployment of application control, and help build that first whitelist that represents your organization. So if I navigate here to the Application Control Policies page, I can create an Easy Auditor policy. And what it's going to do is going to go out and take an inventory of all the executables on the endpoints that I assign it to, and it's going to aggregate that information back on the server. And that's going to give me visibility into everything that's installed on the endpoints that I've assigned this policy to. This is a very non-disruptive process. Unlike traditional whitelisting solutions, I don't need to take back the endpoints and create a clean gold image. I can simply scan the endpoints in situ and build a whitelist based on what's installed on that endpoint at that time. And then over time, I can make decisions about whether I want to continue to allow all those applications to run. So I can progressively take control without impacting user productivity to introduce whitelisting. And all of the policies in the solution and other solutions delivered through the platform use the same type of wizard. So I can go ahead and enable my policy and enable it and set my logging options. And then I can move to the next page to assign the policy to either groups or endpoints. I can either use groups of endpoints which I have custom created, or I can use any of the system created groups which the platform provides for me automatically by IP collection or virtual machines or by different operating systems. Or I can target specific endpoints one at a time if that's what I want to do. I have already set up a test group, so I'll go ahead and assign the policy to that group. When I finish that policy out, the policy would go to that group of endpoints. It would take an inventory of the hard drive of those endpoints, and for all of the executable files that we find on them, we'll collect a lot of information about the file, including file metadata, digital signing certificates, all that sort of information. And that eventually gets returned to the application library. And this is the first step in the process of rolling out application control. What we're trying to do here is to discover the executables that are in our environment so that we can manage them. If I look back on the application library, I can see a list of executable files which have been found on the endpoints that I have assigned those Easy Auditor policies to. And in fact, for any of these files, all of the details are available here for what we found. The application library also integrates with our cloud-based Endpoint Integrity Service, or EIS database, to obtain verification ratings for files in the application library. EIS is a cloud-based library of file hashes which have been obtained from reputable sources, and the ratings provided by EIS are calculated based on whether the hash was obtained directly from the vendors, or it might just be a very prevalent file, and we can use that idea of file prevalence also to provide ratings for files in the library. So these verification ratings you see here represent how confident we are that these files are what they claim to be. In this case, you can see that these files have a high rating. They are Lumension verified, and they are also digitally signed, so I can be very confident that these are legitimate files. Now, what I could do here, before I go into blocking mode or decide to start enforcing application control within my environment, if I see any files, any applications that I don't want to run in my environment, I can stop those from running even before I start enforcing whitelisting. So I've created a group up here in the application groups called Unwanted Software. And what I could do is take files which are discovered in the environment and put them in this group together of unwanted software. So here in this example, I've put Apple iTunes and Skype together in this unwanted software group. They may not be malware, of course, but just for business reasons, we don't want those applications running in our environment. So I can start blocking those applications even before we start enforcing with the whitelist. And I can actually do this for all users, not just those that I have put into Easy Auditor. So that's a very immediate and significant benefit of introducing application control in my environment. I can prevent applications from executing that consume network bandwidth or applications that don't support employee productivity. So I can go ahead and deny this group. I could create a new policy for it, but I can see that I've already got an existing global denied applications policy, so I'll just add this group to that policy. Now, whenever I put an application in that group of unwanted software, that will prevent it from running in my environment. So I can look through the list of applications I've created, and I can see here I have a bunch of games, and simply by adding that application to this group, the unwanted software group, that will block them from running in my environment. You can see here that I've also created a group for approved software, and just as I can block certain applications from running, I can also centrally authorize applications that I want users to be allowed to execute even if they don't exist as yet on their endpoints. I can do this by creating a supplemental easy lockdown or auditor policy. But just as in the case of my blocked applications, I already have a centrally authorized applications policy in place, so I'm going to add that group to that policy. And that really starts the first step of the next phase of application control, which is the define phase. And in the define phase, we've completed discovering what's in our IT environment, and we want to start defining our policies in preparation for enforcement. So a couple of things we can do in the define phase. One is block unwanted software, which I've already shown you. The next thing we need to do is to identify sources of change for our endpoints. Any reason that executables change on the endpoints we need to identify and either block that change or authorize that change specifically. So there are a few mechanisms that we have that would account for that change. The first one I want to talk about is the Trusted Updater policy. The Trusted Updater policy is one of the policies that make up the trust engine, and in this case we have Lumension Patch and Remediation as a Trusted Updater. And because I've got these Lumension Patch and Remediations here defined as Trusted Updaters, when they execute on my endpoints, Application Control will recognize it as a Trusted Updater, and it will add any files to the whitelist that Lumension Patch and Remediation changes or adds to the endpoint. So if I simply use Lumension Patch and Remediation to deploy my system patches or install new software on my endpoints, the Application Control Administrator doesn't need to take any action to maintain the whitelist or add those applications to the whitelist in advance. The whitelist is automatically updated by the Application Control Trusted Updater mechanism. So in this case, we're using Lumension Patch and Remediation. You could trust other software distribution or deployment tools that you use in your environment. There are other updaters that might reside out on the endpoint, such as the Adobe Updater, which you may want to authorize as a trusted updater so that it can update Adobe at the endpoint. Or, if you don't want your users having those updaters run, simply add them to your unwanted software group or group like it, and then those applications will not be automatically updated on the endpoints. So, some types of change aren't quite as clear-cut as to be able to define the particular executable. So there's another type of policy we have here called Trusted Publisher. And Trusted Publisher, the example we have here is WebEx, because WebEx is an example of a situation when we don't have the executable ahead of time to be able to whitelist it. So when you log into a WebEx meeting, WebEx delivers a new executable to update their meeting manager application. So what we've done here is this policy type. A Trusted Publisher policy will allow that software to run based on its digital signing certificate. So if the software is signed by a particular certificate that I have specified here in the policy, or any of the certificates that I could list here, then it will be automatically authorized to run. Again, no need for the Application Control Administrator to get involved ahead of time and make sure that all the right applications are on the whitelist. Simply by virtue of the signature matching the policy, the application will be allowed to run. Another policy option we've got is Trusted Path, which allows software to execute so long as it is stored in the path defined in the Trusted Path policy. This policy might be used for unsigned executables which change frequently and don't have a defined updater, so Trusted Updater or Trusted Publisher could not be used. It could also be used for shared network paths, for example, build-output locations for in-house software development. While allowing applications to execute based on their location might not seem like a particularly secure policy, you can specify ownership restrictions, authorized owners, so that a file can only execute in the trusted path if the owner is as specified in the Trusted Path policy. Files in these paths can also be secured via OS privileges. This greatly increases the security of this trusted change policy while maintaining flexibility to introduce change. I've also got a local authorization policy defined here. This becomes more important later in the rollout process, so I'll come back and review this policy later. We've also got memory injection policies, which can be set up to protect against memory attacks, which can exploit unpatched vulnerabilities. Reflective memory injection is a technique which works by injecting a payload into a compromised host process which is already running in memory. It never touches the host hard drive, so is undetectable by file-based security systems such as antivirus or application whitelisting. Reflective memory injection is a technique you would associate with advanced persistent threats or man-behind-a-keyboard attack, whereby having injected a payload into a running process in memory, the process can then be controlled by the remote loader, enabling confidential information to be stolen, for example. By setting up a memory injection policy, we have the ability to detect when such an attack occurs and automatically end that process before it can be accessed remotely. So that's a very powerful layer of protection against advanced persistent threats or targeted attacks that forms part of our overall intelligent whitelisting solution. As we saw earlier in the application library, in addition to blocking unwanted software, we can centrally authorize applications via the supplemental Easy Lockdown Auditor policy. We already added this approved software group directly from the application library, so we can use this policy to directly authorize software for specific endpoints or groups, even before they have the software installed on their endpoints. So, if we have set up our trust policies and we think we have accounted for all the change that is occurring in our environment, we've blocked unwanted change, we've accounted for the change that we want for those sources that automatically update the whitelist, executing on their own without any intervention required by the application control administrator, we can now come back and look at the application control logs coming back from the endpoints. The application control module can log every time an application is authorized or denied on the endpoint and returns those results back up here to the server for us to review. So, there are several ways for us to look at the logs which have returned, but there is a special query configured to look at what's happening on the endpoints which are in Easy Auditor. And what this shows us are files. Remember, we've just deployed Easy Auditor. We're not blocking anything just yet, except for those we're explicitly blocking using denied policies, but we're not blocking according to a whitelist. This query shows me the applications which have been executed on the endpoints, but which would have been blocked by application control had you been in enforcement mode and been enforcing according to a whitelist. These are sources of change, or things that are going on in the environment which are not authorized by any policy that we've established. So it's important we look through here and review this information. I can see here on this particular machine that someone ran Firefox setup and then ran Firefox. So I need to decide if I'm going to let that user install Firefox. And if I'm not, no problem. I can just leave it unauthorized, or I could add it to my unwanted software group. But if I'm going to allow this to run, I need to come up with a policy to allow him to do that. So we review the logs for everything that would have been blocked and make sure that we're comfortable with that. And once we're comfortable with everything in here being blocked, then it's time for us to move on to the next step, which is enforcement. So to move from this auditing mode into enforcement mode is extremely straightforward. I can come back to my application control policies page and I can select that Easy Auditor policy that we picked earlier. And in there, there's a link right here which I can click and it will convert it to an Easy Lockdown policy. If I were to click Finish, what would happen is exactly like Easy Auditor. It would go out and take another inventory of all of the executables on that hard drive, but this time it's going to go into blocking mode after that inventory is completed and the whitelist is built. So we've converted from Easy Auditor to Easy Lockdown and our endpoints are now in blocking mode. Everything which was authorized at that time is authorized to run. Everything we have authorized through the Trust Engine is also allowed to run. Everything we're deploying with Trusted Updater, software we're installing and patches are automatically being updated. No work required. So now that's in place, now we're no longer susceptible to zero-day malware and things like that. All of that is being prevented from executing on the endpoint. I mentioned earlier on that I was going to come back and talk about local authorization, which is a policy that I can set up to enable users to authorize applications on their own endpoints. Once I've gone into enforcement mode or lockdown mode, local authorization is a mechanism which can be used to authorize blocked applications, particularly in a time-critical situation. You could assign a local authorization policy to a user temporarily, and then review any authorization decisions they had made, and centrally authorize or deny these applications subsequently. However, Local authorization can also be particularly useful just prior to going into lockdown as a transition stage between audit and enforcement mode. In audit mode, users can continue to install new software on their endpoints and introduce unwanted change. In enforcement mode, this will be blocked. While you're still in audit mode, local authorization policies can help to make that transition, because if you apply a local authorization policy in audit mode, users will still be able to make changes on their endpoints. However, now if I look at this endpoint here, the user is going to have to authorize those changes directly, and it's going to be very obvious that those changes will be visible to the administrator. So this starts to drive a change in user behavior before moving into full enforcement. So the final phase, now that we're in blocking mode, is just simply the ongoing management of application control, the day-to-day management which might be required. To do that, we're really going to rely on the application control log queries. Now I want to show you there's a couple of different things you can look at to understand what's happening in the environment. So if I want, I can look at every application that was added by a trusted updater policy and determine whether or not I want to continue to trust those updaters. I can look at applications that were allowed by trusted paths to see if anything unintended was authorized due to this location-based policy. I can see what's been allowed by those trusted publishers to see if anything unintended was authorized by allowing them to run based on their certificate. I can look at everything that was denied, and I can determine again whether that was outside of our company policy and should have been denied, or do I need to adjust my policies or create a new policy to account for it and allow it to run. So we use the application control log queries to review everything that's happening in our organization on the endpoints. And I'll show you an example here of what's been denied. Here I can see that iTunes has been denied because I've put it into my unwanted software group. But if I were to see something in here that I felt should be allowed, maybe this Photoscape application, I could add it to the application library for further analysis, or add it to my approved software policy to include it. And that's all that's required for the ongoing management of application control. This application might be appropriate for my marketing group, but perhaps not my engineering group. So I could assign this to specific groups, and that provides an extra layer of protection against data loss or theft. Having already set up all the trusted change policies we need, the Trust Engine will automatically enable trusted change to occur on our endpoints, automating the process of whitelist maintenance and really reducing the administrative burden to handling occasional exceptions that need to be addressed due to changes in the environment, in end-user needs, or in business needs. That's how easy it is to implement application control within an organization, even an organization that's not made up of entirely gold images. It's very straightforward, easy to maintain from a day-to-day operations point of view. You are simply looking at the exceptions and deciding whether to authorize those. There are many benefits that are introduced by the platform, the Lumension Endpoint Management and Security Suite platform. It helps us when assigning policies to users, when assigning policies to endpoints by grouping those endpoints together, and offering benefits there. And because it's delivered through the platform, along with the other modules that make up the intelligent whitelisting solution, application control, antivirus, and patch and remediation, all delivered through this single console here, all combine to provide a very powerful solution that we refer to as intelligent whitelisting. I would encourage you to go and check out our other videos on the intelligent whitelisting solution and the Endpoint Management and Security Suite platform. You can learn more on our application control webpage at www.lumension.com, and you can get a free personal one-on-one demonstration of the application control solution, or download a free evaluation copy of it. You can also download our free application scanner to understand what's really installed on your endpoints and get an idea of how big your attack surface really is. There's also a lot more information on our website about the application control module, including our application control best practices guide, and how it will deliver you better security and lower total cost of ownership than other standalone alternatives. Thank you.